So let's start with number 3. I like number 3 the best. We're going to go with that. Okay. So we want to find the value of each angle in degrees and radians, and we want to find the exact value. Okay, so we're going to do this by drawing triangles. So to do this, remember that arctangent means we are looking for an angle. We are looking for the angle whose tangent is 1. So we're going to draw this. So remember our cast thing that we just talked about? Now, anytime we're dealing with a positive number, you're going to draw your triangle in the first quadrant. So draw this in the first quadrant. That was so-so. And tangent, remember tangent is opposite over adjacent. So 1, since we don't have a fraction there, we can just write that as 1 over 1. No big deal. So this is telling us our opposite side is 1 and our adjacent side is 1. And we want to know what this angle is. Well, hopefully you can see that that is a 45-degree angle. Hopefully you remember that from your special right triangles. I'm sorry, that is so terrible. So this is a 45-degree angle, or as radian, it is pi over 4. And that's it. Okay, now let's go back and do number 2. We want to find inverse cosine of -1/2. So we're going to draw our triangle. Remember, we're never in the third quadrant for these. And we're going to think about cast. Now, this is a -1/2. So you're not in the first quadrant. That's only a positive. And we're doing inverse cosine. So we have to go to the second quadrant for this triangle. There it is. All right, cosine in SOHCAHTOA, cosine is adjacent over hypotenuse. So our adjacent side is 1. Hypotenuse is 2. And hopefully you recognize this triangle. If you don't, you can use the Pythagorean theorem to find that third side. That third side is √3, which means this right here is a 60-degree angle. However, our answer is not 60 degrees because we're in the second quadrant. 60 degrees is not in the second quadrant. We need this angle. So this angle is 180 minus 60, which is 120. So the inverse cosine of -1/2 is 120. Or when we put that into radians, 2 pi over 3. Okay, let's skip over to number 5. And we'll come back for number 4. All right, so inverse sine. Never in the third quadrant, so we're going to think about cast. This is a negative value, so it can't be in the first quadrant. So when sine is negative, that's in the fourth quadrant. So this triangle is over here somewhere. With sine, sine is opposite over hypotenuse. So our opposite side is √2. Our hypotenuse is 2. That doesn't look like one of our special right triangles, so we'll just do Pythagorean theorem real quick. √2 squared plus x squared equals 2 squared. So 2 plus x squared equals 4. So it looks like x is the square root of 2. Oh, that does look like one of our special right triangles. See, these are the same. So that means this has to be 45 degrees. Actually, -45. Oh, wow, you can't read that at all. That was supposed to be a -45 degrees because we're in the fourth quadrant, remember? So our answer is -45 degrees or -pi over 4. Another way you could have done this problem is if you recognized that number had been rationalized, you could have said, hey, that's the same thing as -1 over √2. And then you would have recognized your special triangle maybe a little faster. Okay, let's check out number 4. Arc cosine of 0. You're never in the third quadrant. We're thinking about cast. Now 0 is not, technically it's not positive or negative. I'm just going to draw it in the first quadrant. Just, it'll be easier that way. Okay, and this is 0 over 1. So cosine is adjacent over hypotenuse, so SOHCAHTOA. So the adjacent side is 0 and the hypotenuse is 1. And that third side, this one's a little weird. that third side is going to be 1. If you use the Pythagorean theorem, this has to be 1. So let's think about this a little bit. If this side is 0, that means this side of the triangle is basically not there, which means this triangle is smashed all the way up over here, okay? Because this side is 0, so we have to pull that in. It's smashed up all the way here, and that is a 90-degree angle, or pi over 2. Okay, so you can draw these triangles with side lengths of 0. They're just going to be smashed up against something, and we'll see that in the next one. We'll go ahead and finish up all these. All right, let's do arc sine 0, just because it's another 0 one. You can see that. So arc sine of 0, remember we're never in that quadrant. We cast. 0 is not really positive or negative, so just draw it in the first quadrant. It'll be fine. So this is 0 over 1. Sine is opposite over hypotenuse, so the opposite side is 0. Hypotenuse is 1. If you do the Pythagorean theorem, that makes this side 1. And what that means is this side is 0. So this triangle is smashed all the way down right here. So our answer is 0. 0 degrees, 0 radians, same thing. Okay, one last one of these is inverse tangent of negative root 3 over 3. This one's probably easier if you unrationalize it. Hopefully you recognize that that is the same thing as 1 over root 3. That's the unrationalized form. All right, so, it's a negative, sorry. So with cast, we're going to draw that down here in this quadrant. Tangent is opposite over adjacent, so our opposite side is 1. Our adjacent is root 3. And then you should recognize that special right triangle. If you don't, you can do the Pythagorean theorem and see that this is 2. So that makes this a 30-degree angle, well, a negative 30 because you're in the 4th quadrant. So our answer is negative 30 degrees or negative pi over 6.